Hey, what's up, guys? It's Walks here. And I've been reminded that I should end this video by saying, please hit that big, beautiful subscribe button, but I feel dirty just saying that right now. Smash the subscribe button. Okay. Back to the business. Yesterday we left off by actually trying out some of our new methods in our linked list class. So we added to the front, we added to the back. We had 2 lists going. We even made a copy of a list by using our clone method. So when I run this code now, okay, we see 7 dog juniper was our list, and then a bunch of doubles, and then our clone also includes 7 dog juniper, but we also, to our clone, added kitten to the front of that list. So that's why it says kitten 7 dog juniper. But all our methods were working right. Okay, so that was good. So let's pick up where we left off yesterday. And the last thing we wrote again was we have length, head, tail. We have our constructor. We have is empty, size, finalize, add to the front, add to the back, and toString. Okay? We then also started writing, we wrote clone, but we wrote some strange methods. In range, which was private, it was a hidden method. Get first node, get last node, and get node. Now these methods were protected. And the reason they're protected isn't going to be clear at first, but because they're protected, I can't call them here. I can't say list1 dot get node. Notice it's not showing up here, or get first node, because they are locked from outside the class. They are protected. So we can't actually access those methods at this point. All right, so we want to write methods that we can access in the linked list class. Okay, so we wrote 2 that can add to the front and add to the back. But I'm going to actually propose something to you guys, a point that my wife always uses with me when she asks me if it's intuitive or counterintuitive, which I think essentially just means, is it natural? So if I said to you, here's a list and add something to it, where do you intuitively assume it's going? Okay, so the word bottom and back came out. Are you two speaking of the same thing, do you think?
Like if you have like say you're going to the store, it'll be at the bottom of the list. Like if you have to buy like eggs, milk.
Okay, well let's do that. Let's forget computer science for a second. Give me a list, a grocery list. Bacon, apples, TP. It's one more thing. Stink? What did you say? Steak. Okay. I could write the list that way. I could also have written it this way. Okay, so I can write it up, down, or side to side. Okay, so I'm changing colors, and we're going to add something to our list. Pick a new food item to add to our grocery list. Something. We'll just put pie. Okay. Where intuitively would you say I add it to this list if I said add pie to it? Right. And where intuitively would you say I add it to this list? Would it be counterintuitive for me to put pie here? Would that be against your, don't do that, Walks. It shouldn't go there. Pie should go over here. Is that more intuitive to you? Okay, good. Which of these 2 is more representative of the linked list? Going this way to you or going this way? I see people doing this. So yeah, so let's do that. This is often done in programming. Sometimes when you use someone's class, you don't want to overthink it. So let's just do this. Let's write a little method in our linked list class just called add. So public void, we won't even make it a Boolean method, add. Add this data. Now this is going to be a really easy method because we've already done this. But we're not saying specifically where we're adding. Let's just go with the instinct. Where instinctively would I add this? You guys said I would add it to the back. So sometimes we do this. Sometimes we write a method that's worded simpler because we assume people are just going to use it that way. And they're going to intuitively just know that it gets added to the back. So if we want, it just makes our coding like we just say list.add, and it adds it, and we know it's going to the back. Okay? So this is, there isn't really a name for this type of method, but it's often done that way, that you just write these simple little methods that end up calling other methods just for the ease of use of this particular thing. Okay. So yesterday, we wrote this clone method. Let me jump down here. It's got some pretty complicated code in it. But it creates a brand new linked list, also of data type T. It loops through our current linked list, which is where this variable is stored, and generates new data of type T by going in and getting the node at spot I, pulling out the data, and then uses this weird thing right here. Now you may forget what that means, but what that little T in brackets means is actually what's called casting. We saw it way back when you first learned Java. You can cast integers into doubles and doubles into integers. And that's what's going on there. We are casting one data type to another. So when you see that little T in brackets, that's used with generics for the purpose of casting. Okay, let's today write the equals method. It's somewhere in our list here. To the which one? The clone method, sure. There you go. Okay, so let's look at the equals method. Right now, it's not a very good equals method. It doesn't actually check to see if the two linked lists are the same. So to look at the equals method properly, we need two linked lists. And right now, we don't have two linked lists. We have one linked list and then an object. So let's start by making a second list, a linked list, data type T, called list, which what we're going to do is we're going to turn the object, this object, into a linked list by casting it again. So in other words, we put the square brackets here, and inside the square brackets, we put this, that we're converting the object into a linked list. So the casting is actually a fairly complicated thing. You can cast things more complex than just integers and doubles. So I'm turning the object into a linked list. All right. Now, how to determine if they're equal? Well, what's a quick way we can tell if two lists aren't equal? One way is if they're different sizes. Right? If one has 20 things in it and one has 10, they're not equal. So let's use that first. Let's say if this dot size is not equal to list dot size, then they're not equal. Let's return false. So that's an easy one. If they're not the same size, we're done. We're done here. There's nothing else for me to do at this point. Now, if they are the same size, the only way we can tell if they're equal at this point is to go through them one by one and check each one, node by node, to see if they're equal. So to do this, we're going to make a node called current1, and it's equal to this dot get first node. And then go ahead and make a current2, and it's equal to list.getFirstNode. So I'm getting one from the list, that's my parameter, which was an object that I turned into a list, and I'm getting the other one from this, which is the linked list itself. Okay? All right, now we know they're the same size, the two lists. That's already been established. So now we're going to use a while loop and say, well, and it doesn't matter which one we use because we know they're the same size. But I'm going to say, well, current1 does not equal a null. So we're going to start a loop to start going through node by node what's going on here. And inside the while loop, we can use an if statement. If current 1 dot equals current 2. We already have built into the nodes an equals method. It's already built into there. If that equals false, so in other words, the two current nodes are not equal, well, we're done here. If all of a sudden the two lists was like 10 and 10, 20 and 20, 30 and 40, oh, we're done. We don't need to check the rest. So let's return false right here. And that will end the loop and end the method. Now, while we're inside the while loop, we have to also keep moving our nodes from one to the next. So we're going to say current 1 equals current 1 dot next. This moves it to the next node, and we have to do that with both current 1 and current 2. So current 2 equals current 2 dot next. So this is, again, some tricky code here that's using nodes to loop through linked lists. So we've taken a big jump here. And then finally, at the very end of this method, if we get all the way down to this very last line, well, all that's left to do is return true. At that point, if we've made it through every single node in the list and we've never returned false, then these two lists must be the same list. They're exactly equal. Make sense? I hope. Okay, so we're going to put this little method to the test. And I want to say little method. It's not that little. We put quite a bit of code into it. We turned it into a linked list. We check the two sizes to see if they're equal. If they're not, we're done. We then get two nodes, current 1 and current 2, and they're not actually nodes, they're just references to nodes. References to the first node of one list, reference to the first node of another list. And while they're not sitting at null, we're going to check to see if what these two nodes are referencing are equal. If they're not equal, we're done. We return false. But if they are equal, we go ahead and move to the next node of both lists. And if we get all the way through the list and nothing happens, then we say, you know what, these are two equal lists. So let's put this to the test. We just made a copy of list 1. Let's see if list 1 and copy are equal. If list1 dot equals the copy, I'll S out that they're equal. Otherwise, I'll S out that they're not equal. So here's what I've done here. I've just said, you know what, I'm going to compare list 1, this list, with my copy. And they shouldn't be equal. And the reason why is because we added kitten to the copy. So they are a little bit different right now. The copy has the word kitten in it where the other one doesn't. So I should see the not equal come out. And I do. There's not equal. Good. But if I take out this line temporarily where I added kitten, now they should be exact copies of one another and they should come out equal. And they do. So our copy method and our equals method are working properly. And that's handy if you have two lists. Like again, if you were making a big game and you had two lists of data and you want to quickly just see, are these two lists the same? A method like equals comes in really handy. Also a method like copy comes in really handy. So you can quickly make a copy of stuff before you go and make any major changes to it. Everybody okay? Equals? Okay.